Okay, in this video we're going to review graphing sine functions. And so this is from Objective 5. You would have first looked at it back in Honors Math 2. A couple of reminders about some vocab. First off, we have that the amplitude for the curve y equals sine x is 1. And this is, again, an unshifted graph or an unaltered function, y equals sine x. Which would have an amplitude of 1 because on the sine graph it goes up 1 and down 1 from its equilibrium or midline value. And so you can see that here in your parent graph of y equals sine x. We can see that this function goes up 1 and down 1 as we work our way across or around the sine graph. Reminder that there's also something called period. The period for the curve y equals sine x is 2 pi. Since it repeats its pattern every 2 pi units along the x-axis. And so again, you can see this pattern, one rotation of sine from 0 to 2 pi. The sine graph itself in the first and second quadrants is positive. So you'll notice in the first 2 quarters of this sine graph we are positive because sine is positive in the first 2 quadrants. And then sine is negative in the third and fourth quadrants. So you'll notice in the third and fourth quarters of the sine graph we are below the x-axis and negative. Now, we then looked at translating this, so y minus k equals a sine b of x minus h. There's a couple of pieces of information you can pull from this descriptive form. First up, you have your hk, which is going to be pulled directly from your descriptive form. Hk on the sine graph is right here, and so it is your starting value. You will then have your final point and your middle point, which will be all in line with your HK. Okay, you have your A here. Now your A is how you will find both your amplitude, so how far up or down we will go, and the direction, or initial direction, we'll call it that, initial direction of the graph. Because amplitude is always a non-negative value. So sometimes this coefficient out here will be, say, -3, but our amplitude is still going to be called 3. The negative simply tells me that the orientation of my graph has been reversed, whereas sine is normally positive for the first two quarters, sine would then be negative for the first 2 quarters. And where sine is normally negative for the last 2 quarters, sine will now be positive for the last 2 quarters. So whether this is negative or positive simply tells you kind of the orientation of your graph. But the value itself of the number, we'll call it the absolute value of that coefficient, will give you the amplitude, how far up or down you go from this midline. And so this distance here is going to be your A. Same thing here. This distance is going to be your A. So the total height of your function will be 2a. Okay, B here is going to be used for a couple of things. First off, we do need to know that this may need to be factored out before we pull out our HK, technically speaking. But that B is actually using your period, and this is actually a typo, so we're going to go ahead and cross off this 2 pi. Period for a sine is 2 pi over B. And so whatever this B value is, say it's 2, we'd be putting it in here. 2 pi over 2 is then pi. And so what that B will change is how rapidly this sine function completes one kind of rotation through its pattern. So again, initially speaking, it's a 2 pi, which is why we start with the 2 pi, but then we will divide it up into however many b's there are. If this is a 3, then that tells us this is going 3 times as quickly. If that's a 1/2, it's telling us that period is going half as quickly. So we'll need to make sure that that is divided through our 2 pi. Okay? And then when it comes to graphing, there are a couple of things we will be looking for. Primarily speaking, in the graph will be the 5 key points, which are the beginning, middle, end, quarter, and 3/4 points. So you can see each of those plotted on this sketch of the translated graph. We will always start with the first one, end with the start with the first one, then go to the last one, then the middle, and then quarters and 3/4. Okay? So, if you are at home using this as a review, I would recommend pausing at this point, walking through several of these on your own, and then restarting the video as you are either ready to check your answer or looking to kind of hear an explanation if you get stuck. Obviously, if this is the lesson for you, then I would recommend watching one or two, but again, eventually pausing the video and trying it on your own, maybe watching the first one and then trying number 2 on your own, and then maybe watching number 3 and trying number 4 on your own. But do at some point make sure you practice without listening to the video, because that way you're getting that gauge. What are you actually understanding? What do you need to come in and ask questions about? Okay? So, number 1, we have y equals 2 sine x minus 1. So first things first, we need to get this into its translated form. So that would mean, move this up here, that would mean getting this to be a minus k over here. So adding or subtracting anything added to the back to the front. And then potentially speaking, it would mean factoring out that b if it had been distributed into the x. And so as I look at this number 1, I notice I don't have anything distributed into the x. However, I do have a minus 1 that can get added over to the other side. And so I'm going to go ahead and do that. This will then allow me to pull out my starting point, my hk. My h in this case is 0, my k is negative 1. And that is, again, your starting point of your sine graph. Your hk is your starting value. Okay, we then want to identify our amplitude and our period. Our amplitude is the a out front. In this case, my amplitude is 2. Again, that's telling me how far up or down I go. In this case, we're going to go up first because that's a positive, and again, sine is positive in the first 2 quadrants. If this was a negative 2, we'd go negative for the first 2 quadrants. Okay? Period. Period is 2 pi over b. My b in this case, the multiplier in here is 1, so my period is 2 pi over 1, which is simply 2 pi. That period helps me get my final point. My final point is going to be 2 pi away from my starting point. So if this is my starting point, 2 pi away would be right here. My middle point then would be at pi. Remember, with sine, your beginning, middle, and end are all in line with each other. And then your quarter and 3/4 points are going to be splitting the difference. And again, our amplitude is 2. So as I split the difference here, I'm going to be moving 2 up from that midline. 1, 2. And then 2 down from the midline. 1, 2. And then I always advise taking a moment, and as you kind of sketch in your graph here, double check that there are in fact 2 between every subsequent point, because that is what that amplitude means. So we have 2 between these 2 values, right, up 2. This one goes down 2, up 2. So I kept my amplitude the same at 2, and we're good to go. Okay. Okay, again, at some point, make sure you pause the video and start trying some of it on your own. Number 2, getting it into its descriptive form. We would be looking, is there anything I can add or subtract over, anything I can factor out? Nothing's been multiplied into the x, so we've got nothing to factor, and there's nothing added or subtracted at the back, so this is my descriptive form. Okay, pulling out your hk then, my h in this particular case would be negative pi over 2, my k would be 0, and so that's my starting point at negative pi over 2, 0. Okay, amplitude is the coefficient out front. In this case, it is 3. Now, yes, I know there is a negative, but remember, amplitude is always a non-negative value, so that negative just tells us our sine graph is upside down. It's been reversed. Okay, but the amplitude is 3. Period is 2 pi over your b. My b in this case, the coefficient inside, is 1, and so my period is 2 pi. Okay, that helps me get my last point. My last point is 2 pi away from where I started. So here's where I started, at negative pi over 2. So we are at 1 pi, 2 pi. 2 pi away from negative pi over 2 is 3 pi over 2. I then can get my middle between these two is right here. And I could do my quarter and my 3/4, splitting the difference again. This time amplitude of 3, and again negative, so we're going to be upside down, so I'm going to go 3 down from my midline, and 3 up from my midline. And again, always double check, did I keep my amplitude consistent as I work my way around my function? Right? Down 3, up 3, up 3, down 3. Yep, 3 all the way around, and so we're good to go. Okay, number 3. Okay, getting it into its descriptive form. We have f of x equals 2 sine of 2x minus pi plus 1. There are 2 things we can do to this one to get it in its descriptive form. First off, we can subtract the 1 to the other side, so I can see my k value. And second up, we do have a 2 that's been distributed inside, so I do need to divide that 2 out. And when I divide the 2 out of pi, I'd have pi over 2. When it comes to factoring, I recommend taking 2 seconds to just double check through distribution. Did you factor correctly? If I distribute the 2, I get 2x. Distribute the 2, I get pi. And so I'm good to go. Okay, HK, your starting point. My h in this particular case is pi over 2. My k is 1. And so that's my starting value. Amplitude and period. Amplitude is the coefficient out front. My amplitude in this case is 2. Period, 2 pi over b. b is the coefficient inside of your trig, which is 2 in this case. So my period is pi. Okay, and so that's my ending point, pi away from where I started. Well, here I started at pi over 2, so pi away would be right here. And that's my ending point. My middle point would be in between. And then my 1/4 and 3/4 points need to be at an amplitude of 2. So I'm going up 2, 1, 2, and down 2, 1, 2. And checking our amplitude, up 2, down 2, down 2, up 2. I'm good to go. Okay, number 4 is our last one, so if you haven't already, pause the video, try it on your own. Okay, number 4, 2 things we need to do to get this in descriptive form. Number 1, add the 1 over. Whoops, that should be negative, sorry. Negative sign. And then number 2, pulling out the 1/2 that has been distributed in, we would have x plus pi. And again, checking your distribution, make sure you factored correctly. 1/2 times x is 1/2 x. 1/2 times pi is 1/2 pi. Okay? HK, my starting point. My h in this case would be negative pi. My k would be negative 1. And so that's where I'm starting, negative pi, negative 1. My amplitude in this case, the coefficient out front, is 1. Now it is negative, but again, that does not affect amplitude. Amplitude is always positive. The negative just tells us that our sine graph is upside down. Okay? Period is 2 pi over b. My b is the coefficient inside, which is the 1/2. Remember, dividing by a fraction is the same thing as multiplying by its reciprocal. So my period is 4 pi. So that's where I'm ending. Starting here, I'm going 4 pi away, 1 pi, 2 pi, 3 pi, 4 pi. That's my ending point over here. Middle value in between is at pi. And splitting the difference again for my 1/4 and 3/4 points with an amplitude of 1 and making sure my sine graph is upside down. My 1/4 point is going to be down 1. My 3/4 point is going to be up 1. And then again, one more time for this video, go ahead and make sure as you look between your subsequent points that that amplitude stayed the same. Down 1, up 1, up 1, down 1. And so I know I'm good to go. Okay, that's graphing sine.